Hello, Professor Kara and Ventai. Today I'll be introducing you to what I've built over the past couple of months and how to work with that. So first we start by SSHing into the server. All right, so we are in the server. Now we will activate the environment. All right, we have activated the environment which I've created. So now I will go inside the function, like where I keep the EDGNet, engineering drawing net. So let's go inside the documents. All right, so we are inside the documents. And let's go inside the EDGNet. So let me quickly go over what we have in here. So we have the line data set here. We have the source. We have the line data set test. We have the train, and we have the test. So before I start doing the testing, let me remove the previously created models I have trained for demonstration purposes. We will be redoing those. So let's redo things. RM. Okay, we have successfully deleted the regular outputs. I will show you what those are, but let me remove those first. All right, so I'm also removing the other, the PyTorch version. No worries, we will be regenerating those. So I will start by presenting what's inside the line dataset. Let's go inside there. So inside the line dataset, we have two things. One of them is called processed. The other one is called raw. We always delete the processed after each run. Processed is generated automatically once you start training a model. So let me remove that as well. All right, so we are left with a row. Let's go inside row and see what we have inside the row. So this is where we keep all the NPCs. NPCs are actually kept inside this line dataset.zip. I can delete all of these NPCs. And basically, as long as this line dataset zip is in here, these NPCs will be extracted from it after, like, each time you click, if each time you train, these get extracted. So it's an option. You may you may delete these, you may not delete these. It's fine. It won't extract as long as it sees the NPCs are there. But if you change the line dataset.zip, please change whatever you would like by changing this zip file. So again, so I have shown you what's inside. Like, we have like I've introduced you to this load. So let me um, quickly go back and show you what's inside the line dataset test folder. It's highly likely that I will see another process file in there. All right, so inside here, we'll also see, oh, I already deleted that, so it's completely fine. As long as it's raw, it's fine. So now let me show you the code. So the code is inside the train.py, and train.py is where we do the partitioning of the data. So it usually, I mean, in the past, this was done automatically, but as you requested me to test on specific data sets, I have like modified it a bit. So right now the version on the server is the most updated one, and let's go inside that now. So what's inside the row previously, like on here, is like pretty much the same stuff. So let me actually go there and just show to you what we have in there one last time. All right, so as you can see, we have like 1, 2, 3, 4, 5, 6, 7, 8, 9. So usually like this is 7. This is the 7 real images out of the previous data set. These are unseen. I do not show like the synthetic versions of these inside the train. So these are completely unseen, but from the previous data set, I put them here for demonstration purposes as usual. And like these another copy and copy are here because those are used as dummy variables for test and train and validation. So that's how the PyTorch like I've read about this on PyTorch geometric discussion forums. That's how they do it. So you create one dummy for validate validation and train, so that you can test however many data you like with your already trained model. Okay, so let me just move out. So now we have the train.py. Let's see, let's go inside train.py, right? So inside here, I commented the code like throughoutly, as you can see here. I mean, without the NPCs, no one would be able to work on this. So I feel comfortable sharing the code on a public YouTube video. So here, as you can see, like you can pick which data sets you like at the very beginning. You can select the number of epochs. You can select your learning rates. For now, we are on CUDA. Previously, I was using CPU while I was, for example, running some tests of my own. So basically, like I commented this. If you read this, I'm sure that you will understand what happens inside the code. So as you can see, when you say GAT, it goes inside that model.py, which is under source. I will also show that to you, and it brings GAT and does the training with the GAT. So besides this, and the most important part is we are saving the model, right? This is what was requested from me on the previous ones. We are saving the model, and we are saving the outputs of the model, meaning that after each epoch, we get a print statement. We also save that. So besides that, I do not think that I have much to share. On this end, I am checking my notes to see if I have anything. I've like prepared the presentation thing almost, so that I can go through each and every question that I had. that's basically how it works. So I will quickly run it. Okay. So how you run it is you say Python train.py, right? So when you say Python train.py, what's going to happen is it's going to go inside this line. It will go inside this line data set. It will do the training and it will save the output as a PT. Like it will save the model as a PT here. I have a bunch of models trained already. They are somewhere inside the server. But right now we're just demonstrating things. We're just demonstrating that the whole pipeline works and like which file we use for what. So let me quickly run this. So as you can see, it first prepares the data and then it prints the outputs, like the parameters we entered, right? So we are right now we are training with 30 features. We actually have 38 features. So I mean, I will also show you how to edit that. Like you can increase, decrease, select a bunch of features so that you can do feature-wise analysis. I will also go through that. So for demonstration purposes, I trained it for 10 epochs. Now I will show you how we test this model on our test set. So for this purposes, I created I read a bunch of PyTorch geometric and PyTorch discussion forums about how to load models once they are saved so that they can be tested on completely new data. So I will go inside the test now so that I can show you what happens in the test and how I load the models. So this is the test. As you can see, this time last time we were selecting. Now we are testing, right? So we are reading the weights essentially. We will read the weights. I mean, in the upcoming parts. So I also wrote a lot of comments for each part, which part does what. So I think this will be clear when I read this code. But what I want to say is like we use this code in order to test the already saved models. Okay. So Q. Now what we will do is I will test this model on our test set. Okay. So the test set is line data set test. It has 7 images, and once the test is done, it will also show the confusion matrix for each prediction, because like we were kind of sensitive about how if the model is going to be able to understand like if we are looking at a contour line or dimension line. So all of that will be transparent. So let me run this Python test py. All right, so it quickly went inside this line data set tests and it saw the 7 it saw that there are 1, 2, 3, 4, 5, 6, and 7 graphs, just as how we like 7 MPZs, and it tested the model. I mean, the accuracy came out to be 73, but this is like an 86 or somewhere around 85, 86 when the model is fully trained. As you see, we trained it for like 10 epochs here. Yeah, I also mentioned the reason why we had 2 dummy variables inside the raw test, because those are dummy variables. One of them is for train, one of them is for validation. Without putting any data for chain and validation, you cannot use the PyTorch or like the internal packages. So those are all placeholders. Don't worry about those. So you basically use this test as pi in order to test the model that you have. Okay. Besides that, I'm taking a look at my notes here because I really don't want to miss anything here. So as usual, like we will do what we have done at the beginning. Okay. So I will go inside the line. I will go inside the line data set. Line data set tests. And like once you do the testing, you will see this process here, and you always have to delete it no matter what. Like you really wouldn't want to not delete this because it causes a lot of issues. So yeah, that's an important note that I would like to share with you again. So now I will present you what's inside the source. Source is a rather old like code that I've created a long while ago, but I also made some changes there. So I think it would be valuable, like it would be good to know. So we are inside, oh, sorry. So let's go inside source. So inside source, what you will see is the line dataset.py and model.py, okay? So let's go inside line dataset.py. All right, so we're inside the line dataset.py. It's pretty good. So I also have like comments throughout the code. If you'd like to learn what each part does. I recall that there is an important part which I would like to show you. It should be around here. So that's how we. Okay, so it's here. So as you see, I wrote this with capital letters. So the label. So we currently have 36 features. Okay, not 38. I recalled it incorrectly. So 36 features. I found out that the first 6 has issues. So once you exclude the first 6 and only use coefficient of variance and Zernica moments along with the X, Y, Z axes, you will find out that like the tests come out a bit like the accuracy comes out a bit higher after you do the training. I will also share where those models are located with Ventai. But for now, like we are demonstrating this, so we can see that you can, for example, pick you can exclude the first 6 features and just use the last 30 features. If you like know NumPy, then you should be able to arrange that. So this is the last column. Besides that, okay, so besides that, I do not see any notes, any important notes. Maybe I can also show you what's inside the model pie. Model pie is where we keep our models, right? So I will not be sharing those models because, I mean, I will not be like showing the code in this video, but inside the model pie, you can see our models, right? So besides that, I do not think that we have anything. I think the most important thing here is test py. This is what Ventai requested. For me, it loads the model, it does the testing. It's a completely separate thing on its own. So this is part one of the part one of my presentations, which introduced you to what I've done in EDGNet. Yeah, so hoping to see you on part 2 where I demonstrate visualizations for island detection, line deletion, and so forth. Goodbye, and thank you for listening to me.